The Atlas. It's a strategic and tactical military airlifter designed to be all things to all air forces. It's been almost 3 decades in the making, costing the partner nations more than $30 billion. Does it deliver on its promises? Or is it an overpriced political compromise? Join us now, up front in the cockpit, as we seek some answers. Ed Strongman, A400M Chief Test Pilot, is our instructor today. He's been with the program since first flight in 2009, and no one knows this aircraft better. A400M was launched officially in 2003. Avionics and systems architecture borrow heavily from Airbus A380, but they're extensively modified for its role as a military airlifter. This is the first turboprop airlifter built in the West to have full fly-by-wire flight controls, a full 3-axis system similar to the A380. But there are plenty of software modifications for its role as a military aircraft. A400M, for example, can be banked up to 120 degrees, and pilots can pull up to 3 Gs for tactical maneuvers. Like A380, the cockpit has 8 large format flat panel displays, but they're positioned and used differently. There are 3 pairs of screens in the main panel, but no dedicated primary flight displays. Instead, the left and right side head-up displays are certified as primary flight displays, as they are in the Lockheed C-130J. The head-down displays can be configured as needed for each phase of flight and for each type of mission. Starting the engines is easy. I'll just switch on the fuel pumps on the overhead panel, turn the engine start knob to start, and then switch each engine master from off to feather. The FADEX handle everything else. I can feel some vibration as the engines start to turn, and the huge 8-blade props stabilize at about 180 RPM. The vibration all but disappears when the engine masters are switched from feather to run, and the props speed up to 650 RPM ground idle. Serial number 6 is the aircraft we're flying today. It's a pre-production model with an operating empty weight of slightly more than 177,000 pounds. The payload today is only 880 pounds, so the zero fuel weight is just over 178,000 pounds. With 55,000 pounds of fuel on board, we'll push back from the chocks at about 233,000 pounds. Our computed takeoff weight is just over 232,000 pounds. Based on using flaps 1, roughly 10 degrees. The V-speeds are 110 for V1 takeoff decision speed, 122 for rotation, and 129 for the V2 engine inoperative takeoff safety speed. Flap retraction speed is 148. Toulouse Tower directs us to line up and wait on runway 14 right. Ed is running through the final pre-takeoff checks, arming the ground spoilers and the auto brakes. Takeoff technique in this airplane is not vintage Airbus. From idle, we rapidly push up the throttles to the stops. Full power in 4 seconds. Similar to a turbofan aircraft, there is no power-induced yawing moment or P-factor because each pair of props on a wing rotates in the opposite direction. We pitch all the way up to 20 degrees and accelerate through V2 and flap retraction speed. We'll climb to 3,000 feet to clear downtown Toulouse and accelerate to 250 knots. With gear and flaps retracted, we pull back the throttles to the managed power detent. In this position, the auto throttle system is activated. But similar to a civilian Airbus, the throttles don't move. They're not back-driven to provide visual and tactile cues of system operation. Crossing overhead Toulouse, we'll use LNC, or low noise contour, to reduce prop speed to about 650 RPM for noise abatement. Low-level navigation at night, or in obscuration, is this aircraft's strong suit. The aircraft has a high-resolution infrared camera for enhanced vision that can be displayed on both head-down and head-up displays, as you can see when I hold this sheet of paper up behind the HUD. It also has a high-resolution digital terrain database that shows we're safely clear of the Pyrenees. With 40,000 horsepower, pulling back to 40 degrees nose up means an initial climb rate of more than 7,000 feet a minute. Let's climb up to flight level 310, the maximum altitude for which the aircraft is EASA certified, and check cruise performance. At a weight of about 227,000 pounds, long-range cruise is 0.68 Mach. In ISO -5 degree conditions, speed is 394 knots true, while burning 7,700 pounds per hour. Speeding up to the aircraft's 0.72 Mach red line, the aircraft easily cruises at 417 true at ISO -5, using about 63.5% power. Let's go down to 14,000 feet and sample the aircraft's low-speed handling characteristics. We'll set 121 knots for VREF, assuming gear up and flaps 4, roughly 40 degrees of flaps. With power at idle, when the aircraft reaches speed floor, angle of attack, low speed protection triggers to avoid the stall. Now let's disable speed floor and attempt to stall the aircraft at idle thrust. And there we are. The nose is sinking at about 98 knots. Side stick all the way aft. Maximum allowable angle of attack, just a little less lift than stall. No wing roll-off, no loss of control. Now let's try to stall it while using full climb power, about 32,000 horsepower up here. Watch the deceleration on Ed's PFD. The fly-by-wire system takes into account prop wash over the wing that enables the aircraft to fly at a higher angle of attack without stalling than with power off. There, 78 knots, 20 knots slower than with power off. With full aft stick at maximum allowable angle of attack, the fly-by-wire system just nudges the nose over, again with complete controllability throughout the recovery. Let's return to Toulouse. We'll turn downwind to the south of the airport for our final approach. We use an assault landing profile with a 12-degree glide path. Here we go. 3 miles from the runway, idle power, speed brakes fully extended, and we take the plunge. The approach is steep, but quite comfortable. Now let's retract the speed brakes, advance the power, and transition to a normal 3-degree glide path.
150.
Yeah, pretty much stay.
100.
Okay, gear down.
50. 40. 30. 20. 10. 5.
Touchdown. Using full brakes and prop reverse, we stop in about 1,600 feet. With practice, I'm sure I could cut that by at least a third. Overall impressions? A400M definitely fills the gap between the C-130J Super Hercules and the C-17 Globemaster III. It's a freighter, a troop transport, a medevac ship, and a tanker. It can use short, rough runways like a STOL prop plane and also cruise at 420 knots, almost as fast as a jet. But at more than $170 million, it's the most expensive turboprop ever built in the West. However, with more hot zone threats coming to Europe's doorstep, the Atlas may become a bargain for the stakeholders.